Hi, my name is Richard Coombs. I'm a solution engineer on the Google Maps for Work team, and this video is an introduction and demo of the Google Maps Roads API. There's a number of different APIs that make up the Google Maps API family. These APIs offer a wide range of location-based capabilities that you can use in your own systems and applications. Some of these include something as simple as embedding a map and then overlaying your own data, or viewing street-level imagery with Street View. You can do data visualizations, including heat maps and animations, or find optimized directions, distances, and travel times, as well as getting detailed information on businesses and points of interest. We're constantly making additions and improvements to these APIs, and we recently launched the Google Maps Roads API. The Roads API leverages Google's accurate and up-to-date road network information that you see in Google Maps. Currently, there are two main features of the Roads API: Snap to Road and speed limits. So let's take a closer look at these features. There's many GPS-enabled devices that can record latitude and longitude coordinates, ranging from hardware embedded in vehicles to fitness trackers to smartphones. The original GPS points, or breadcrumbs, that are captured by these devices can vary in accuracy due to signal strength, line of sight to the sky, and environmental factors, like if you're near tall buildings. These original GPS points may not always align with the road network, as you can see here. The Roads API's Snap to Road feature can take these original GPS points and snap or align them to the nearest road. Not only this, but Roads API can also fill in missing points between the original GPS points to ensure the path closely follows the curve of the road. This is called interpolation. This interpolation gives you an accurate and realistic visualization of where the asset has moved. The speed limit feature provides a government-mandated speed limit at each location on the road. That means you can find out the maximum allowed speed limit on the roads your asset or vehicles traveled along and compare it with the actual speed. Speed limits are available in either kilometers per hour or miles per hour. So what are some of the reasons you'd use the Roads API? As I showed in the previous slide, you get a much better representation of where your assets traveled. You probably don't want your users to see messy GPS data. Instead, you get great visualization of GPS data nicely aligned to the road network. Accurate distance reporting that an asset or vehicles traveled on is important for things like fuel cost calculations, insurance premium calculations, expenses reimbursement, and maintenance planning. Roads API can help get a more accurate understanding of distance traveled by cleaning up original GPS data, especially in urban environments when GPS signals can bounce off buildings and provide misleading data. With the ability to get road speed limit data, you can compare this with the asset's actual speed and therefore better understand how safely the asset is being operated. As a Roads API can interpolate or fill in points between the original GPS points, you can therefore capture fewer points. If your GPS device runs on battery, this can help improve or lengthen battery life. A lot of asset tracking companies need to provide reports on where the asset has traveled. Roads API provides a unique place ID for each road section. This ID can then be used with the Google Geocoding API to determine the name of the road and neighborhood. This can greatly reduce the amount of geocoding required and also provide improved reporting. Another use case for the insurance industry is simplified capturing of accident information. By using a smartphone to take a picture of an accident site, you can automatically determine the accident location, road name, and road speed limit. I'd like to quickly touch on a few technical aspects of Roads API. So the API is a web service, which means it's very easy to integrate into your system or applications, whether it's web-based, mobile, or a back-end server process. This URL is an example of a Roads API request. Let's break it down quickly. This is the base URL, or address, where all requests get sent. I mentioned the two main features of the Roads API are Snap to Road and speed limits. In this example, I'm using the Snap to Roads endpoint. Next comes the API key. This is used to control access and make sure nobody else uses your quota, as well as track your own usage. Instructions on how to get started are at the documentation link shown here. Next, we can see the Snap to Roads interpolate parameter, which is set to true. This is followed by the original GPS points. Up to 100 GPS points, or latitude and longitude pairs, can be sent in a single request to the Roads API. So this is what a Roads API request looks like, and this is what a response looks like. Here you can see an array of snapped points consisting of the snapped latitude and longitude, the original index of the point so you can tie it back to your original GPS points, and the place ID of the road segment, which you can use to look up the road name via the geocoding API. Just a quick note about usage limits before we get into a demo. There's a free limit of 2,500 requests per day, but above that will require a Maps API for Work license. I think the main thing to highlight here is that the speed limit data is only available with the Maps API for Work asset tracking license. The Roads API is part of the Maps API family, so it isn't sold separately. When you purchase a Maps API for Work license, you'll get access to it with these higher limits. Okay, with that, let's see it in action. This first demo I won't actually show, but I wanted to call it out that it's available in our documentation pages. You can draw a line on the map and see how Roads API will snap it. The main demo I wanted to show you uses real GPS data. Feel free to give it a try yourself. So let's jump in. The purpose of this demo is for you to be able to use your own GPS data and see what Roads API does. The GPS exchange format, or a GPX file, is a format for sharing GPS data, and this is what this demo uses. So here you can see I've got a GPX file. I've recorded this using the MyTracks Android app. I should point out that the main focus for this demo is to show the Roads API in action rather than handle every flavor of GPX file. I've had success exporting GPX files from a Garmin GPS device and the MyTracks Android app. So now I'm going to drag and drop the GPX file onto the map. This has automatically sent the data to the Roads API and performed the snap to road and speed limit requests. Let me give you a quick tour around what we can see here in the interface. I can change the map style to the default Google map style or the satellite layer. I'm going to keep it with my custom map style. Down at the bottom I have a chart showing the actual speed versus the speed limit. I can mouse over to see where the location in the chart corresponds to the map location and also click to take me there. If I want to zoom into a particular area of the chart, I can resize it and show the corresponding location on the map. I can then maximize back to the original view. Over here on the right we've got some stats. I can see the date and time and duration of this journey, as well as the GPX distance versus the Roads API distance and the difference between the two. Also the number of GPX points versus the number of Roads API points. Because we're using interpolation, the number of Roads API points is quite a bit higher. And also the percentage of this journey that speeding occurred. Above this, we have some options. On the map you can see the original GPX line in magenta. I can turn this on or off, as well as show the original GPS points. Some of these points are in white and some are in yellow. This is to depict the batches of 100 GPS points that get sent to the Roads API. I can also show where speeding occurred visually on the map. So here red depicts where speeding happened and green where no speeding happened. So let's zoom in and take a closer look. Here you can see the magenta line is the original GPS data, and in green you can see how the Roads API has snapped this to the road network. I can hover over one of the original GPX points to find out a little bit more information, as well as clicking on a road segment to view Street View at that location. I can also view Place ID, which would then be used in the geocoding API to find out the road name and neighborhood, for example. If you want to test this out yourself, you can just use some of the sample data provided. So let's head back to the slides. So if you do want to test it out and record your own GPS data, the MyTracks Android app makes it super easy. You can change the recording interval settings in the app. Once you've recorded a track, you can export it to the GPX format and then share it. Thanks for listening. If you've got any questions about Roads API, please don't hesitate to get in touch with either the Google Maps for Work team or one of our local partners. And don't forget to check out the documentation on the Google Developers site.